it is giving a better result. Is it clear? So what machine learning will do? What can it do? It can do many things. For example, you know, in your Gmail or any email, you have spam emails also and non-spam emails also. This is one of the best example of machine learning classification problem. What is classification? I will explain you very soon. So here, the machine, once you click some email as spam, all the related emails for the next instance onwards will automatically go to spam email. I think you might have noticed it. So this is one example of machine learning, right? Now, there are two kinds of machine learnings. One, supervised learning. What is supervised learning? It is similar to the person who is learning a bicycle with the help of somebody. Here, in learning, supervised learning happens with the data. There is a help from the data itself. So how data will help? Will data speak? Data will not speak directly, but one of the column in the data will help the machine to understand the significance of the other columns. So that particular data is called as labeled data. I will tell one example. The weather is very, very hot outside and it is having bright sunshine. The temperature is 40 degrees Celsius. So these three are independent variables. But based on these three, there is one more column called as yes, you can play, no, you cannot play. So there are some records with some 4 columns. So the first 3 columns, you will say they are independent variables. Why? Because my temperature varies, my weather report, my weather forecast can vary, but based on the weather forecast and temperature, whether I should allow the children to play outside in the outdoor or not is based on those first 2 or 3 columns. Then such kind of data or data set we say is called as labeled data set. When you say labeled data set, and if it is a machine learning algorithm, then that learning is called as supervised learning. So what is supervised learning? Inside the data, we have one column which will help the machine to understand the problem which we are going to target. Now, coming to the machine supervised learning. Supervised learning is again having 2 categories. I will come to unsupervised learning later on. Today I am going to cover only supervised learning in a detailed manner because everything cannot be covered. There is another one called as unsupervised learning. I will show you the data set and the difference. Unsupervised learning, you will have data, but you will not have the labeled column, the target variable, which will help the machine to get the help from the data itself. So unsupervised learning is a true sense of artificial intelligence where the system will learn by itself without anybody's help. This is like learning a bicycle without taking any help from the elder. Is this clear? The difference between supervised learning and unsupervised learning?
Yes, sir.
Okay. So let me just show you how a supervised learning data set looks like, how labeled data set looks like. I'm opening a small data set here. Now I hope you are able to see the Excel sheet.
Sir, visible, sir.
Yeah, I will come to this in detail. There are 4 different features. This is some flowers data set, which is a very common one, iris flower. And based on the sepal length width, petal length width, the species is defined as iris setosa. Suppose you come to the end, you can see there are some more values, it is virginica, and there are some more values, iris versicolor. What I mean to say, there are features, for example, the first four features, they are independent variables. They are not dependent on each other. But based on these four values, you have a species that is labeled column, target variable, response variable, etc. So data set looks like this. Data set looks like this. Now let's go to unsupervised algorithm also. Just to show you, just a minute, I'm just opening and showing you an idea of just a second, guys. Sorry, I took time. Now I will show you. Let's see another data set. Okay. And you will understand the difference between the data set which is used for supervised and this is unsupervised learning. Here you have number of years of experience and you have salary. Okay. There is no help or labeled data here. For example, you observe the first record. Somebody has 1.1 year experience. Their salary is 39,000. But there is another person, 1.5, but less salary than the experienced guy. You are able to understand? Sometimes less experience has more salary. Sometimes more experience has less salary. And sometimes more experience, more salary. Are you able to understand what I'm saying? Here, there is no standard help from the data set itself, which experience will get how much salary. Now, such kind of data set, if it exists, and if the machine has to learn, then this comes under unsupervised learning. I hope I am clear. Now, in supervised learning, there are again two categories. One, classification, another, regression. What is classification? Very simple. If the data is categorical data, then what is a categorical data here? For example, what is a color? Green, blue, yellow category. How is the weather outside? Very sunny, overcast category. What is the mood of a person? He is angry, he is happy, he is very sad, he is not having any expression, neutral expression. That is categorical data. For example, a mail is a good non-spam mail or if it is a junk mail category. Then what is non-categorical data? Numerical values. If it is non-numerical, it is called as categorical data. If the data is non-numerical, then the problem what we are going to solve is called as classification problem. Now, coming to the numerical values, then the problem with numerical values is called as regression. For example, house price prediction, stock price prediction, height and weight prediction. These are all numbers. So simple. You play with numbers, it's a regression problem. You play with that is non-numerical data called as categorical data. We say it as a classification. For example, you give set of images of cat and dog and you give a new image and the machine is going to identify the new image is a cat or a dog. It is called as a classification problem. Is it clear?
Yes, sir.
Okay. Now, let's talk about classification problem. Now, when you talk about classification, it's something like yes or no or 0 or 1. If the classification has only two classes, it can have more than two also. Either it can be yes or no sometimes, or it can have multiple classes also. If it is having only two possible classes, then it is called as binary classification problem. For example, you are from a EEE department. You are reading the vibration of a machine. In a machine, there are vibrations, so you are reading the vibrations. Based on the vibrations, you are going to identify whether the machine is going to be faulty or not. Either faulty or non-faulty. Only two possible outcomes. Then you will say this problem is machine learning binary classification problem. For example, you are going to work on a smart grid power distribution and you want to identify whether somebody is actually taking the power illegally. So power theft happened or not? Yes, happened, or no, it did not happen. Got it? What I am saying? So this is also a binary classification problem. Okay. Now, suppose if it has more than two, then it is called as multi-class classification. That I will tell in the next session. Now let us consider a binary classification problem, right? Mathematically, any classification algorithm will have an output function termed as y when it is mapped with an input variable termed as x. For example, y is equal to f of x, where y is the categorical output. Y is the categorical output. What is x? X is the input variable. Then what is f? F is the function. F can be a model. F can be a model. It can be k-nearest neighbor algorithm. It can be SVM. It can be naive based. It can be even multiple of multiple methods where we say ensemble techniques. So what I mean to say, mathematically, we can say y is equal to f of x. Y equal to f of x, where y is the outcome, x is the input. Then, for example, if the possible outcome is only two, as I said earlier, then it is considered as a binary classification problem. Now you can see here, for example, there are two classes. Two different data points are there. One with the shape of a triangle, one with the shape of a circle. Now you can say by just visualizing it, right? You can say class A is the circle data points, class B are the triangle data points, right? So this is one example of binary classification problem. Okay. So as I said, there is another possibility which will have. My session will over. Okay. So I have the key. Binary classification is only possible too, but in my next session, I will also explain multi-class and multi-label where there is a possibility of having more than one class. Then there are two again different types of learning mechanisms. One, lazy learner. Another one is maybe rapid learner or eager learner. Now, what is a lazy learner? Lazy learner will take the training. I will also explain what is training data set and what is test data set. Very simple. You will take the data set. Imagine 1,000 records are there. Very example. 1,000 records are there. So first, you will feed the data to the model. Then it will take the data, process it with the model, and it will gain experience. Usually, we may take 70-30 or 80-20 split. More training data, then more experience machine will learn. The more the data you give with the training data set, the learning is also proportionate to the amount of training data you are giving. Then you take some portion of test data, then you will test the model whether the model is coming correct or not. Very soon I am going to show you practically also with Python coding, live coding examples I will show you. So in lazy learner, what happens is it will store the training data set and it will wait till the test data set is also given. So for example, KNN algorithm is a lazy learner. Okay, then we will see in detail what is KNN. There is another learning type typically called as eager learner. What it will do, it will take more time for training and it will take less time in prediction. So for example, decision trees, naive artificial neural networks, etc. Right? And some amount of theory I have to cover so that we can understand the practical knowledge also. Now, different types of classification algorithms. As you know, the difference between linear and non-linear model. So linear models, you have logic regression and SVM. In non-linear model, you have KNN, naive decision tree, kernel SVM, random forest. We are not going to cover anything, but at least KNN I am going to cover. Now let's just take a couple of minutes short break because I am continuously talking. I just give a 2-minute hold here. We will continue. If you have any doubts till here, you can ask me. You are able to understand the flow I am explaining. Is it clear or any confusion is there? You please let me know.
அப்புறம் இது சண்டே ஒரு நாள் போகும் சார் வர சண்டே பர்மிஷன் கேட்டு
நீ அதுக்கு பர்மிஷன் தெரியல. நான் சொல்லி ஐடியா சொல்லிட்டேன். சரி, இந்த மாதிரி ஆஃபர் அனுப்பிச்சிருக்காங்க, நேரம் வச்சு இருக்காங்க சார், பாத்துட்டீங்க நேரம் வச்சு இது ஆஃபர் வாங்கிட்டு சார் நீங்க சொல்லி 2 நாள் போட்டு ஓகேவா? திரும்ப அங்க போய் ஆஃபர் வாங்கிட்டு சார் இங்க
அன்மியூட் ஆயிட்டு இருக்கு சார், ப்ளீஸ் மியூட் யுவர் ஆடியோ.
2 நாள் போடுறது
சார், ஆடியோ மியூட் பண்ணுங்க. Okay, I request our coordinator to mute their audio, please. Sundararajan sir, உங்க ஆடியோ அன்மியூட் ஆயிட்டு இருக்கு. Right. So let's continue, participants. Let's continue and thank you. In the chat messages, I am getting positive response. That's good. Right. Now let's go and try to understand what is k nearest neighbor algorithm in machine learning doing for classification problem. Okay. So here it is a very basic and easily understandable approach. This works based on the distance between the data points. Basically, in a simple terminology, see, I don't teach with a lot of definitions, because if you can understand the concept easily, you can really read the definitions and you can remember. So I always believe in understanding the concept rather than mugging up the definitions. In k-nearest, it is also called as proximity-based algorithm. Proximity-based means distance-based. What is distance here? Distance between the data points. For example, you take some data points, you brought one more new data point, and you want to know this new data point belongs to which kind of group. Then we calculate the distance, and whichever getting the maximum, we will say this belongs to some class. So as simple as that. So what is k nearest and k nearest neighbor algorithm? Here k is an integer value. Here k is a integer value. For example, sir, what kind of integer it is? It's a positive integer, and it's not a it should not be 0. I will tell you uh, the details about how to select k very soon. So here you take, for example, 5 as k. That means 5 nearest neighbors distance will be calculated. Basically, distance will be calculated between one point to all other points. One point to the new point to all other points, but which is the 5 nearest neighbor, that will get the classification into that particular category. Right? Now, I will show you a theory we can skip. Now, let's try to understand here. There is one data point which I have highlighted in blue color. Now you want to identify whether this new data point belongs to category A or category B. Then how KNN will work? KNN will work in this way. Very simple. First select the number K. How to select, I will tell you. Then calculate the distance between the data point, which, for example, here the blue color data point. You will calculate the distance between this. You will calculate the distance between like this. You will calculate the distance for this, and then whichever is coming nearby, whichever gets the majority, that will be the outcome of a category. Now, there are so many distance metrics. I think everybody knows what is an Euclidean distance. There are other Manhattan distance, Hamilton distance. There are several distance metrics that you can follow. But by default, the distance metric is in general Euclidean distance. Now, so you select the number k, then you calculate the distance. Then among these data points, you select the nearest k neighbors. Whichever is getting the maximum, that will be the category. It's as simple as that. Okay. For example, you see here, we have a new data point. Now I want to know whether which category this belongs to. Imagine, just imagine as of now, k is 5. Imagine k is 5. So what I will do, I will calculate the distance between that new data point to all other data points, right? For example, you see, I think everybody knows about the Euclidean distance formula, root of x2 minus x1 square plus y2 minus, here x1, y1 are the coordinates of one data point which you want to take, and the other data point is x2, y2. Now you calculate the distance. Imagine a scenario like this. 2 blue color category B are near to it. 3 green color data points are near to it. So 3 is the majority. Category A will be the new data points category. Like this we will do. Any doubts here? Now, the question is, how do I select the k value? How do I select the k value? We can select the k value. We can select the k value randomly. There is no mathematical model to define the k value. Okay, so how do I select them? Usually what we do is, in general, you should not take even number as k. Sir, why I should not take even number? Very simple. In cricket, every time if there is a ODI series or anything, usually they say 3-match series, 5-match series. In test only they will say 1 or 2, because test there is every possibility of match also. So what I am saying is, odd number is only the tiebreakers. For example, you take k equal to 4. 2 points are near to category A, 2 points are near to category B. Then where I will categorize which suppose if there are odd number, then there is always a tiebreaker. Is it clear? In general, k is not even. Then k should not be small value, very small, like 1, 2, like that. Why? Why? Because if you take 1, it leads to more noise. Why? Because everywhere, for example, you will get everything you will get. Means from this category also you will get one nearest neighbor, the other category also you will get nearest neighbor, one more category is there, you will get nearest neighbor. Then how you will choose? So what we do in research work is, we take different values of k, analyze the accuracy or any other performance metric, and then we choose the best of the values by trial and error basis. Is it clear? Is it clear?
Yes, sir.
Okay.
Yes.
Now let's see a typical case. Imagine you have taken k equal to 3. Imagine you have taken k equal to 3. Now I highlighted in the PDF. When you take k equal to 3, one star point is there, which is class A. 2 triangle points are there, which is class B. Now our machine learning algorithm will say the yellow question mark data point belongs to class B. But what will happen if I say k equal to 7? Same data point, k value differed. Now you see, if k is equal to 7, 3 data points of triangle are coming, but 4 star points are coming. So there is every possibility, based on the k, your category may change. So that's why we go with trial and error basis and select the best k value. But there is no formula available to select the k value. Okay. So how do we select? As I said, there is no predefined statistical methods. So you will take random k. You should not take a small value, because decision will be unstable. You should not take so much big values also. And you go with the minimum k value, the optimum k value, which gives the minimum error rate. Sir, what is error? Error is nothing but how much you are deviating from the actual value. You have some data, right? And you know the data point also. I am talking about supervised learning. Then you test it, then check whether it is the actual value is equal to the predicted value or not. Okay. Now let's come and try to learn some practical concepts here. Right now I am opening a program. I will explain every line. I will explain every line with a simple example. Now I am going to take a very simple example. Then later we will go to a complex example. Okay. So I love to explain via coding. So don't worry about the number of lines and all. Right. Let's go to the PDF also. You can see here we have a Python library called as scientific kit learn library. In shortcut, it is SCIKIT Scikit learn library. What scikit-learn library offers is, scikit-learn library has so many models of machine learning developed inside it. So we can make use of scientific kit-learn library, and we can actually learn, or we can actually work with several machine learning models. So, sir, how to install this, where it is available? It is very simple. You have to just type pip install scientific kit learn. Scikit learn. This is the, right now I have already installed it. So it will say requirement already satisfied. But in case if you want to install, this is the way you have to install. pip install. Now, every line I will explain. If you are not understanding, please let me know. A simple example I am taking. Okay. The first one in Python, I took a list. Line number 3. I am taking some different combinations. The weather forecast, sunny, overcast, rainy. Different values I took. A simple list. You can see line number 3 is a simple list. Then line number 5. I am taking another list called as temperature. Hot, mild, cool. This is the combination. So you have 3 unique values in weather: sunny, overcast, rainy. In temperature, you again have 3 different values, that is hot, mild, and cool. These are 2 different lists. Now I am taking one more list. Consider this is the target variable. Ideally, weather is one feature, temperature is one feature. Now you see the first value in weather, sunny, first value in temperature, hot. Outside it is very hot and sunny. Play. No, that means do not play. So in the data itself, play is the target variable. So this is very much applicable to supervised learning. Is it clear? I have taken 3: weather, temperature as input variables, independent variables, and then I am taking one more, that is target variable. Is it clear? Is it clear?
Yes, sir.
Sir,
Okay.
yes.
Yeah. Now, when you install sklearn, you can see here, when I tried installing, it said requirement satisfied, because I have already installed it. Now, sir, where do I get this? Let me open the, say, as a faculty, when you are learning something, we should learn in a way where we will explain the students in the better manner where they will understand. Now, I am still using a old version because I don't want to update and get into trouble. So this is my Python home. But for you, maybe you will install in a different directory. Then you will go to Python home. Inside Python home, there is a library directory. Inside this, there is something called as site packages. Every library which is installed in Python will go to this particular directory. So here, for scikit-learn, when you install, it will come as a subdirectory sklearn. So this is the place where my sklearn is installed. Sir, how I know? You can clearly see scikit-learn is installed here. That's exactly what I have opened in another command prompt. Now, if you just list there are so many things which will come. Okay, I will few things I will also explain. Few things I will also explain. Okay, I cannot explain the entire library, but one or two I will explain. Now, let us try to understand line number 9. Let us try to understand line number 9. From sklearn dot preprocessing import label encoder. What is this? sklearn is the package. Then what is dot? If there is sub package, let's go and see. Now you can see there is a sub package called preprocessing. Inside this, we are trying to import label encoder. We are trying to import label encoder. Now I will ask the participants in line number 11. I highlighted something. Label encoder, open parenthesis, close parenthesis, dot. What is this label encoder according to you? With a programming perspective.
It is a function.
It is a function. Okay.
So it's basically
Anybody
used
else?
to convert to numerical values.
No, no,
Because KNN
yeah.
works only on numerical
No,
values.
ma'am, I didn't label encoder does. I just told when it is written like this in a program, what exactly is this? Somebody said it is a function.
Yes, it is a function.
That's what I am expecting. Not what label encoder does. Okay, this is not a function. This is not a function. It is not a method. This is the place where I'm sorry to say I'm not pointing to this particular group of faculty. In general, faculty is not getting clarity between a method and a class. Why? Because of late, I'm very sorry, I'm very frankly telling, I'm not pointing to anybody. We don't write any coding. We only tell theory, right? That's why this label encoder is not a function. It is not even a method. It is basically a class. There is a difference between a class and a function. There is a difference between a class and a method. Fit underscore transform is a method, but label encoder is a class. Sir, how can you say it is a class? So what we have to do? We should do Python postmortem, not the real Python snake postmortem, whereas we should do the postmortem in this way. Where is it available? Inside sklearn preprocessing. Now when I say it is available, so I have to open and see. But if I open and see here, I don't understand where exactly it is there. There are so many Python files here. Any time, remember, you want to understand any library, go inside that library and open the init file, which is the beginning of any package's execution. So I opened the init file. Now inside the init file, you will be able to understand what you are searching. So what I am searching? Label encoder, correct? No. What I am searching? I want to search what is label encoder does, or what exactly is label encoder, right? So I open the init file, then I have to search where exactly it is there. See here in line number 32, import label encoder. From where? From dot underscore label. That means label encoder is available inside another file. Dot means current directory. And I think you know about dunder methods, single underscore, double underscore. As we are not teaching Python here, so I'm not stressing too much, but we have to search whether underscore label.py is available or not. Yes, it is available. What is dot here? Dot means current directory. Yes, it is there. Now we have to open that. See, Python hides so many things. So that's why many people say Python is easy, sir. Python is not easy, or C language is not difficult. You should open and see what exactly is there. Now here, there are so many things, but what we are looking for? We are looking for label encoder. What is label encoder? Clearly it is written, it is a class. So just because there are parentheses, you should not think it is a function or a method, right? Because class will have constructors. Constructor can be called as a method only, right? So label encoder is a class. Label encoder is a class. Okay. Now, when we tell this is a class, what it does? Now let us see what it does. Label encoding is one pre-processing technique where for categorical value, you will get some encoded numerical values. Because this class is not about the entire pre-processing, so simply I am explaining. For example, you have sunny, overcast, and rainy. Alphabetical order you have to do. What label encoder does is it will take in alphabetical order. In alphabetical order, what happens? Which alphabet will come? M, N, O, P, Q, R, S. So M, N, O, overcast will come first. Then overcast will be getting a label 0. M, N, O, P, Q, R. R will come next. Rainy, R will be 1. Sunny comes last. Sunny will be 2. So what is label encoding? Label encoding is converting the categorical value to the numerical value. Then you will get a doubt. Why should I convert? Why? Because many machine learning algorithms expect the data in numerical values. But you have categorical data. What do? You pre-process it. Label encoder, one-hot encoding. There are some many techniques. So here I am using label encoder. I am using label encoder. So let's go to the code now. So if you want to learn more about it, I showed you how to go inside and see which is a class, which is a method, what are the arguments that will go, what are the default values, everything you can go inside the predefined library files and you can see. Now, inside label encoder, there is a method called as fit transform. What it will do? It will fit and transform the categorical data into equivalent numerical values. Is it clear? Line number 11, is it clear? Let's continue. Similarly, now what will be the outcome? Encoded weather. Weather is sunny, overcast and rainy. Then you will get combinations of 0, 1, 2. Similarly, what I am doing is for temperature also I am using the label encoder. Then here also for temperature I will get some values. Then whether to play or not, that also I am using the same encoder. So finally what I did is I have taken the category values and changed it to numerical values. Now this is a small example, right? Here weather is a list, temperature is a list. They are completely two different lists. It is not a data set here. So what I am going to do is I am bringing the combination SUNNY sunny and HOT hot together. Second instance, sunny and hot together as a tuple. Then overcast and hot, rainy and mild. I want to pack them in a tuple. How I am going to pack? Here in line number 23. Jet IP zip will pack the values into a tuple. So what this will do, it will take the first value from the encoded weather, first value from the encoded temperature, it will pack as a tuple. All the tuples I am converting into a list. Finally, I will show you in the PDF itself what outcome will come. Clearly you can see sunny got value 2. Again sunny 2. Overcast 0. Rainy 1. This is encoded weather. Similarly, encoded temperature. After that, what I am doing, I am combining the features. Clearly you see, first value in encoded weather is 2. First value is encoded temperature is 1. Now you see 2 and 1 is one combination. Okay. And based on the combination 2 and 1, if the combination is 2 and 1, basically sunny and 1 is hot. Play is 0. Do not play. Now you see the next combination. Third combination 0 and 1. What is 0? Overcast. It is overcast and it is hot. Yes, you can play. So basically what we got is, we got the input features and the outcome variable. This is about data. Now what we have to do? We need to implement k nearest neighbors binary classification. So let us see line number 28. Let us see line number 28. Now in line number 28 we have from sklearn dot from sklearn dot neighbors import k neighbors classifier. Now again what we have to do? If you really want to know, right, you have to go to the site packages. Inside sklearn there is neighbors. Yes, it is there. It comes with practice. Again list the values. I don't know where it is written. What I have to do? Simply go to the init file. I am going to the init file. Now you see where it is available. It is available here in line number 12 from dot. Dot means current directory, underscore classification. That means you have to go and see whether underscore classification is there or not. Yes, it is there. Go here. Now you have to see, yes, there is a class called as k neighbors classifier. So this is also not a method. Just because there are parentheses, you should not get confused and confuse the students. Right? Now, what it will do, as I said, you see here, default k value is 5. If you want to change, you can also change. Okay? It will calculate the distance. Everything is written. There are so many concepts here. You can also go and you can see. Here you see how the distance metric is happening, how pairwise distance is calculated. Everything is written here. Okay. Let's continue. I hope I am visible to you. There is some power problem here. Anyways, now let's go to the code. You see how simple it is. You are defining the model, my model, or x equal to y equal to, my model equal to k neighbors. You are just defining the class. You are actually instantiating. You are actually calling the class. That means you are creating an object of that class. The moment you call the class itself, basically an object will be created. Okay. Now, with that object, here you are saying n underscore neighbors equal to 3. You don't send here. You don't set any argument here. By default, instead of 3, 5 will go. But here I am exclusively mentioning 3. So my neighbors will be 3. Then see here, my model dot fit the features What are features? It is coming from line number 23. What is line number 23? The combination of weather and temperature values are my features. So I am sending the features, and then I am also sending the encoded label play. What is encoded label play? That either play or not, 0 or 1. Now here learning happens. Here line number 33, learning happens. Now once learning happens, I need to predict the outcome. I need to predict the outcome. So what I am sending here, you see, my model dot predict. Here predict is a method. Fit is a method. Fit is a method which can be called from the object of class k neighbors classifier. Predict is also a method which can be called from the object of class k neighbors classifier. So here what is happening? I am sending some different values of features. For example, 0, comma. What is 0, comma 2 here? 0 means overcast. Sorry, sunny, MNOP, yeah, MNO, correct. Overcast. And 2, cool come first. Hot comes next. Mild comes 2. That means it is cool and mild. Whether I can play or not, we will see in the outcome. So 3 different combinations I am sending. You can see the predicted output also. For example, in the PDF, this is the execution. So it says in the first feature which you are sending as 0, comma 2, it says yes, you can play. That is also true. Right? Now, how to know whether the predicted outcome is correct or not? For that, we can have classification report. For that, we can have a classification report, which I will tell you. Let me give a small gap here. Again, a 2 minutes break, so that you will digest what I said and you will ask me if you have any doubts. So let me execute the program and show you in the live what is the outcome. Now you can see the outcome also, right? Yeah. Any doubts here? You please ask me. In case if you have any doubt, at this point of time, if you have any doubt, you can ask me. I stopped my session here. Now the 15 minutes, it is a question and answers, and then we'll take a 5 minutes break because it is a back-to-back 3-hour session. So I also understand the difficulty in online. So I stop here. If you have any doubts, I will clarify the doubts in this session. Then we will continue with the other topic with multi-class classification and multi-label classification by using KNN classifier. So if you have any doubts or if you want to give any valuable feedback, you can also give me so that I can revamp the way I am explaining. If it is okay, it is fine. If you want a different kind of explanation, I have to adapt to it in the next session. Yeah, up to the organizers now. I am done with my first session. Any question and answers you have, you can please ask.
இல்ல நீ வந்து